In this video, we're going to look at an example of problem solving with primary trig ratios. So before we get started, there's two terms that I want to go over with you. Angle of depression and angle of elevation. So angle of elevation and depression, they're actually the same angle measure because of the Z pattern. These are parallel lines. What they refer to is if something is below something else. So we've got a ladybug here and a person looking down. So from the ladybug's perspective, if something is looking upwards, the angle between the horizontal and that line of sight looking up, that's what the angle of elevation is. Similarly, if something is looking down at something else, so we see this person is looking down at the ladybug, the angle that their line of sight makes with their horizontal is called the angle of depression. So the most important thing to remember when you are labeling an angle of depression or elevation is just check to make sure that it's touching a horizontal line. That's really important. So it's the angle of whatever this is typically a line of sight and a horizontal line. So let's take that information and we're going to try to draw a triangle that matches this situation here. So it says Brandy's a photographer taking pictures of the Burlington Skyway Bridge. She's in a helicopter hovering 720 meters above the bridge, exactly 1 kilometer horizontally from the west end of the bridge. So as we read this, I'm just going to start drawing what we hear. So I see here we've got a bridge. And then we have somebody that's in a helicopter over the bridge. And I'm going to write never eat shredded wheat here, northeast, southwest. And it says she's in a helicopter hovering west of the bridge. So this is where Brandy is. She's in a helicopter. Ta-da! Hovering 720 meters above the bridge, exactly 1 kilometer horizontally west. So the height that the helicopter is at is 720 meters. And she's 1 kilometer horizontally from the west end of the bridge. So we know that this here is the west end of the bridge and this is the east end, just because of our directions. The skyway spans a distance of 260 meters from east to west. 2,650 meters from east to west. So this whole bridge is 2,650 meters. So I'm going to change this guy. See how this is kilometers, this is meters? I'm going to change this to 1,000 meters. Obviously this is not to scale. Okay, so let's make sure that we've got everything. Brandy's a photographer, she's taking pictures, she's in a helicopter hovering 720 meters above the bridge. Really that should say above the ground. Above the bridge may make you think it's this way, but what this really means is above the ground. Exactly 1 kilometer horizontally from the west end of the bridge. The skyway spans a distance of 2,650 meters from east to west. From Brandy's position, what are the angles of depression to the nearest degree of the west end of the bridge? So I want to change just one thing. We're going to say west end and east end. So we're just going to add that in. And east end. Okay, so we're looking for the angles of depression to the west end and the east end of the bridge from Brandy's perspective. So if we're looking from Brandy's perspective, let's connect her line of sight to the west end and to the east end of the bridge, since that's what the question's asking for. So we're going to draw a line this way. We're going to draw a line this way. And now what angle are we trying to find? We're trying to find the angle of depression. So that makes sense because we're looking, Brandy is above what she's looking down upon. So we know that An angle of depression comes from when somebody's looking down at something else. So this makes sense. So the question is, where is the angle of depression? Well, an angle of depression back up here, it's connected to a horizontal. See that angle there? One side of it is touching a horizontal. We don't have a horizontal here, so we can make one. So here, I've created a horizontal from Brandy's perspective, because that's what we're looking towards. So now what are the angles that we're looking for? The angle's depression to the nearest degree of the west end and of the east end of the bridge. So here's our west end. We'll put a little W. Here's our east end. So the two angles are between the horizontal and the east end, and between the horizontal and the west end. So here are two angles. We're looking for this angle. That's for the west end, so that's going to be a certain degree. And then we're looking for this angle here. This is for the east end. So let's work on them one at a time. Let's find this angle here. So what I have here is I have a right angle triangle, and then I have another non-right angle triangle. And right now we're just dealing with SOHCAHTOA, so we can only work with right angle triangles. So if I take a look at this right angle triangle here, if I find this little angle, then I'll be able to find this angle here because they are complementary angles, which means that they both add up to 90 degrees. So here's what I mean. I'm just going to pull out this triangle here. I'm going to just pull it out there. If I can find X, which is here, then I can find W, the degree to the west end of the bridge, by just taking 90 degrees and then take away X. So let's find X. Sometimes I find it's too difficult to see the problem in the original picture, so we're just going to pull out the triangles that we're going to use. So we've got a right angle triangle, so we can use SOHCAHTOA, so let's go through our steps. So here we have the triangle labeled. This one's our hypotenuse. Across from the angle we're talking about is opposite, and then we have adjacent. Let's do our list next. We have the opposite side, we have the adjacent side, and this time we need the angle. So what ratio uses opposite and adjacent? If you look at SOHCAHTOA, that means that we're going to use tan. So here we go. I'm going to start off with tan of an angle is equal to opposite over hypotenuse. Let's fill in what we know. We don't know the angle, but we do know opposite, which is 1,000. And sorry, I made a mistake. It's not opposite over hypotenuse, it's opposite over adjacent. Adjacent. Okay, so we know opposite is 1,000 and adjacent is 720. So to find our angle, we're going to use tan inverse. And we get an angle measure of about 54.25 degrees. So what did we just find? If we put it back into our original, we found this little guy here. This little guy here. We found that this one was 54.25 degrees. So can we find W now? Yes. Well, this is from this line, dotted line, to this dotted line, that's a right angle because we've got a right angle right here and we drew a horizontal. So how can I find W? I'm just going to do 90, take away 54.25, and that's going to give you our W. So here we go. If we take away 90 and the angle that we just found, we get 35.75 degrees. So that's our angle W. How about our angle to the east end of the bridge? So we now know this guy here, we know this guy here, but that doesn't really help us find this one. We need another right angle triangle to help us find this guy here, and we have one. There's a second hidden right angle triangle, so we've got, so we have this right angle triangle right here, dun, 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 dun. But then we have a second one right here. Let me highlight it. Look at this one with this side, and this side, and this side. So we've got this other right angle triangle that's hidden, and this is going to help us with this angle right here, because if we find this guy, then again we can just do 90, take away this guy, and we get this one here. So let's draw this one out. Alright, so what are the dimensions that we know about this triangle? So we know that this is a right angle triangle. Okay, so we are just drawing out the dimensions of this big guy here. So here's our E. That's essentially what we're looking for here. We know this side length, it's going to be 720. So we're going to write 720 here. We also know the bottom side length. right here. It's going to be 1,000 plus 2,650, so it's going to be 3,650. And what we're looking for is this angle here, because it will help us find this little guy right here by taking away 90. So I'm going to call this, we can call it whatever we like. How about Z? Let's call it Z. So now all we have to do is solve for Z. So we're going to do it in the same way that we did it before. We're going to label, so we know that this guy is our hypotenuse. This one's our opposite because we're talking about angle Z. This one's our adjacent. If we do it a list, it's going to be the same thing as above. We have adjacent and opposite. So what angle or what ratio should we use? We should use tan. So if we write out tan of our angle is equal to opposite over adjacent. If we fill it in, we have tan. Instead of theta, I can also put Z is equal to opposite, which is 3,650, divided by adjacent, which is 720. So now if we want to get Z by itself, we're just going to do tan inverse of that whole ratio. And let's go ahead and find it. It's going to be 78.84 degrees approximately. So how does that help us here find E? So what we just found up here was this angle right here. Whoops. From here to here. We just found this one was, it was 78.84 degrees approximately. So now we can find angle E by just taking 90, take away this guy, and we'll be left with E. So let's do that final step. So our angle E is going to be 90 degrees. Take away what we just found, which is 78.84 degrees. And we get approximately 11.16 degrees. So if we were going to do a concluding sentence, we would say the angle of depression from Brandy to the west end would be this guy, and the angle of depression from Brandy's helicopter to the east end is this. So this was a long problem. Most important is drawing out a sketch. This would be really, really difficult to do without a sketch. And then if we want to work with SOHCAHTOA, just remember that sometimes it looks like there's only one right angle triangle in there, but usually there's multiple. And if it gets confusing, finding all the triangles within this one picture, just break it up into multiple triangles so it's easier to work with.